What's up, everybody? Welcome to this week's episode of the Well Man's podcast. My name is Brian Brozy. I'm joined by my friend and co-host Keoni Tita. Keoni, how are you today?
I'm good. Thank you, everybody, for being on the podcast and listening to us once again. Please spread the word.
Yes.
Today, I want to talk about aging, and the reason why I want to is because I feel like by mitigating that or slowing it down, we can actually stop disease processes and make everybody healthier. So I read this
Sounds important.
Yeah, very much so. We actually had a podcast on this, Brian, way back. And we talked about the mechanisms of aging. So I just want to go into a little bit more detail. And one book that I just recently read that I recommend people get, because this podcast kind of follows that and is basically taken from this book. It's called Lifespan by Dr. David Sinclair, PhD. He's a Harvard researcher. Mm-hmm. He's done a lot of research on aging. Specifically, he's the one who, I don't know if he's the one, he's discovered the sirtuin genes, but anyway, he discovered genes that actually, if you turn them on, it actually helps slow down the aging process. So now there's this whole anti-aging movement, and it's not just like a pie in the sky type thing. It actually seems like there's a lot of stuff that we can do to help slow down that process. So we talked about this in a number of podcasts with, kind of stressing the body a little bit through like fasting, or talked about cold temperature, hot temperature, and stuff like that. We'll talk about that in a little bit here.
Mr. Sinclair at least looks the part. If you look at a picture of him, he looks young and youthful, and he's all of that without being plastic.
Right. And I think he's 51, 52 years of age or something like that.
Yep.
So yeah, he looks really young. So yeah, he definitely looks the part. So anyway, I recommend that book for anybody who's interested in health, because as I said, I think if we focused on slowing down the aging process, if we focus on that, then we also are stopping the disease process,
right,
and prolonging life extension with quality of life. So it's not so hard to prolong life, but what's the quality of that, right? We can keep somebody alive forever hooked up to a machine and all that stuff. But
right,
really what we want to do is we want to prolong life and keep the youth there.
Yeah.
So his book is really, really great. So we're talking about really, slowing down the aging process, even reversing it. So anyway, there's this. So why would we even want to do that is one thing, right? Because a lot of people talk about.
Well, are we going to touch on, Keoni, where are we at with all this? Because I know you and I have chatted about CRISPR, like different technologies. Is this, where is this right now? Is this, just in Sinclair's lab, or is this stuff we are seeing in some way, whatever it may be, be brought to commercial use or whatever?
Well, right now, he's the one who kind of brought all this to light, but there is so much that we can do. I mean, it's basically stuff that you can do now, in your own life. But to answer that question specifically, yeah, some of this stuff is being done in the lab, and different molecules and medicines to help slow down the aging process are there. There's also lots of technology there where we're actually talking about replacing parts.
Mm-hmm.
Where you take stem cells and you can make stem cells into any type of cell that you want. Let's say you have a congestive heart failure, your heart is failing, you take a stem cell, and by giving it the right signals, you can make a whole new heart and basically put it in you. So it's basically like, think about, it's almost analogous to a car in a sense, right? In theory, a car should be able to last forever. And all you do is just replace the parts as it breaks down. Well, that's one aspect of this whole, longevity thing. With technology, we'll be able to do replacement parts. With technology, we'll be able to do nanotechnology, right? Where you can have little nanobots going through your bloodstream and fixing things as they go through there. I mean, this stuff it sounds like science fiction, but it's really just around the corner.
Yeah.
But that's not so much what we're talking about now. That's like,
right.
what can we do now, lifestyle wise, and as far as nutraceuticals to help slow down that process? So maybe we can make it to that place where we can significantly extend longevity.
Gotcha. All right. So the
Right.
tools that we need to hopefully get to the future are here, and then we're waiting on the future.
Yeah,
Or we got to
right.
get to the future.
Right. So he, Dr. David Sinclair and a bunch of other people in this anti-aging research really think that right now it's theoretically possible that people should live to about 150 years. So if you live to 150 years old, then you get to that point, where's technology going to be, right? It's probably going to be so far advanced that then you could probably extend it another 50 years, and then you get to that place, you extend it another 50 years. So I hear a lot of them saying, and I think he said it in the book, that right now there are people living that, a bunch of people living that are going to make it to 150. So, and you're going to make it to 150 youthful and quality of life. You're not going to be decrepit and bound to a wheelchair or anything like that.
To what degree, Keoni, are we talking about David Sinclair's kind of educated but opinion versus what does the consensus say on kind of our achievable lifespan, like that 150-year-old marker?
So there's a little bit of controversy out there, but I think David Sinclair and others are kind of turning it upside down. So it used to be kind of scoffed at that, the normal human lifespan is, maybe 100 years old or whatever, 90 years old. And the oldest known documented person that we know of that's documented, she lived to 122 years old. That was Jean Clement, French woman.
Yeah, I do remember talking about her in that old
Right.
podcast and then butchering her name. So if you want to hear that,
Yeah.
I would definitely check it out.
Yeah. Yeah. So anyway, that's the longest known, but there's been throughout history, there's been, anecdotal stories about people living a lot longer.
Okay. So the longest person that we know of lived 100.
That we know of that's documented lived to
22?
122. Yeah.
22.
Almost to 123. But and it's very interesting because she definitely didn't have the healthiest lifestyle. She
I think
basically
we said something on the podcast. She did something
she smoked
a day.
she smoked till like she was 90 or something, so yeah, some people are just, kind of have good genetics, but you can actually, with the genes that you have based on some lifestyle things, you can significantly reduce your risk of disease and help yourself get greater lifespan and health span.
Okay.
And so the other thing that's very interesting is if you think about the natural world, right? It's almost like there's something out there called the Kirkwood hypothesis of aging. And basically it says that all animals have evolved to allocate energy to reproduce or for longevity, but not both. So an example of this would be, think about birds that can live close to 100 years, whereas mice, they're, they could, I don't know, they don't live any more than 2 years, maybe 1 year at the most. And so basically what mice do is they allocate their energy to reproduce. And the reason why they do that is because they know that they better reproduce before they get picked off by a bird of prey, right? It's like, yeah. So whereas the bird of prey allocates energy towards longevity and doesn't reproduce as much, right? So that's kind of like, it speaks to Darwinism to some extent. But what's really interesting about humans is we've kind of taken ourselves out of that in a sense, right? Because we're top of the food chain. We don't really have to be worried about being eaten by bears or anything like that, or reproducing fast or anything like that. We spend a lot of time nurturing our children. We basically don't live a stressed life like, let's say, a mouse would, like significantly stressed, where we have to reproduce, and we know if we don't reproduce that we're going to get eaten or we're going to die. So that hypothesis is kind of fascinating. There's some controversy with it too, but it has a lot of evidence kind of backing it up.
Okay. It is interesting how as soon as we're kind of explaining it, I see how maybe we were there and then we've completely
Right.
like you're mentioning, kind of removed ourselves from that Kirkwood
Yeah.
theory of thinking.
Yeah. It is interesting though, because there is a kind of some backlash on this whole anti-aging thing. You know, every there's a lot of things out there that come and go as far as anti-aging. Like one of the things we were talking about back in the 60s, you know, when they came out with uh, oral hormone therapy, like giving estrogen and stuff like that, testosterone and things like that, where, you know, this was like the new anti-aging thing. And there was something to that, but it wasn't what we found when we actually looked at the studies. It didn't give the evidence that we needed to say that, so to speak, right? It helped in some ways, but not in a lot of ways. So for example, I remember back in the 80s, growth hormone was the big thing, you know, inject yourself, get growth hormone. And, you know, there's some anecdotal evidence that showed growth hormone had many anti-aging attributes, but then what we saw was that when people actually took it, their mortality increased.
Okay, good.
On it, you know?
Yeah. Well, that almost speaks to this Kirkwood hypothesis, because you're I guess constantly growing to kind of reproduce and survive, but you can't do it forever
to
at that rate.
To some extent, yeah, it's too much too fast, maybe.
Yeah.
So anyway, so what they found was actually that people who actually don't have a lot of like growth hormone around, like IGF or insulin, they actually tend to live longer. And they found like centenarians, people who live 100 years or more, centenarians live 100 years or more, they actually have lower levels of these hormones. And it's also fascinating to see that people who, when we talk about this Kirkwood hypothesis, who are very tall or very big, you know, tend to live shorter than people who tend to be of shorter stature.
Yeah.
And
same for dogs. I mean, like Great Danes versus Chihuahua, the lifespan expectancy is huge.
Yeah, there's definitely something to be said for that. So it kind of fits that hypothesis. And also going on that hypothesis, that we also found that in humans, right, that it was found that castrated men tend to live a little bit longer than their fertile counterparts. Okay, so that kind of speaks to that too, a little bit. Also, women who tend to get pregnant early in life, as opposed to women who tend to get pregnant later on in life. Okay, so who tends to have the shorter lifespan? It'd be the ones who have more time to reproduce. So the women who tend to start having children early in life tend to have a shorter lifespan than the women who tend to have children later on in life. So that also speaks to it too. So
I would keep my wiener and live a shorter life.
Yeah. Hopefully what we're going to talk about now will allow us to keep that, and
we'll have
live
the best
a longer
of both
life.
worlds.
Yeah,
awesome.
we'll have the best of both worlds. So that's why we're talking about
I await with bated breath.
Yes. That's not the goal of this podcast, to get castrated men out there. Yeah. We will prevent that from happening. Anyway, so species, again, are resource limited except for humans. So humans kind of, it seems like, have the potential to fall out of that, right? We're at the top of the food chain. We can resource allocate for longevity instead of reproduction, that type of thing. And there's ways to do that. And the other thing I also want to talk about, which is, this book is really fascinating, and it's a really easy read, but he talks about aging is not really caused primarily by DNA mutations, right? So that whole free radical theory kind of is turned upside down, or is not necessarily true, right? So that was another aging phenomenon that went on, I think, in the 80s and 90s. You know, the more antioxidants you eat, the less likely you're going to create more, you'll quell those free radicals. So therefore you don't get DNA damage, and therefore you don't age, right?
Yeah, and with our understanding that, go ahead. Yeah, sorry.
So that has been debunked. And one of the ways that it has been debunked is, we do know that right now, I think in the early 80s, there's a sheep named Dolly that got cloned. Do you remember that?
Oh, I remember Dolly.
Yeah. So anyway, Dolly lived a good amount, pretty good amount of time. But again, there are a lot of issues with Dolly, and ended up dying. But Dolly was a clone. But Dolly was taken from an older cells from another animal and cloned, right?
Mm-hmm.
What we find is those older cells, you would think, well, those older cells have been around long enough, so therefore they have more free radical damage and DNA damage and so on and so on.
Okay.
So therefore you would think, well, of course, Dolly wouldn't live that long. But since Dolly, numerous animals have been cloned, and what they're finding is that when they're cloned, they actually live, just as well as their non-clone counterparts. All right. So that's pretty significant if you think about it. So you're taking a cell from an adult animal and then cloning them, and that clone lives just as long as that animal normally would. And you're thinking, well, that can't be possible, because you would think these cells have all that it was cloned from have all this DNA damage, right? So the cloning of animals kind of turned the whole free radical idea upside down a little bit on aging. It didn't throw it out completely,
right?
But there's something else going on there.
Okay.
So we know that, and actually we prove that. We know that you can't take, I don't know, 50 grams of vitamin C, every day of your life. I'm just throwing that number out there. It's a huge amount, but to stop the aging process and quell free radicals, you're still going to live about the same time as somebody else if you take all these antioxidants. And maybe taking all these antioxidants may work against you. Okay. And it may be that the body's not getting stressed enough to use its own endogenous antioxidant mechanisms to slow down the aging process. You're putting all this exogenous stuff in your body, right? So there's something to be said for that, said about that. And actually, just to bring this up, many oncologists kind of tell their cancer patients, especially when they're giving them chemotherapy or radiation, don't take a lot of antioxidants, all right? Because the whole thought is that they'll quell free radicals that the radiation and the chemotherapy generate to help kill the cancer cells, and you don't want to do that. So I bring that up because really what you want to do is you do promote your body's own innate way of quelling, free radical damage, or you want to bump up the body's own innate way of all its biochemical processes to slow down the aging process. And there's a number of them out there, and it's just not about free radical stuff, free radical damage. So, and we talked about this on a podcast long ago. I think it was like 3 years ago, where we talked about mechanisms of aging. I forget the podcast number, but so what are they? Pretty much, I mean, they're genetic instability caused by DNA damage. That kind of speaks to free radicals. So that's kind of one. So if you're getting little nicks in your DNA over time, that DNA doesn't have repair mechanisms as well, and the messages that the fidelity of that DNA to get passed on is kind of ruined, so to speak. But what we find is that's really not a big deal, because if you bump up the other anti-aging processes, a lot of times DNA has a very good fidelity and could actually help repair itself to a significant extent. This is one of the reasons why men, because of this, can have children well into their 90s or 100, if they're healthy.
Is because of what exactly?
So what I'm saying is DNA at the genetic level, nuclear DNA has strong fidelity, right? So you would think, like, over a lifetime, that with all this DNA damage that from the free radical theory of aging, that men would not be able to reproduce. But in fact, we do see that they do. they can later on, well into late life.
Mm-hmm.
Whereas
Mm-hmm.
women can't because their hormones change and everything. But in theory, if they could back that up, women still could too, because
Mm-hmm.
women at postmenopausal still have, eggs there.
Mm-hmm.
They just don't have the hormonal machinery to enable them to get pregnant anymore. But anyway, so I just want to bring that up. So I think people can just put that free radical thing off to the, it didn't bear out the way it should, in theory, the way it should. Like, you take a bunch of free radicals, you can slow down the aging process, you make your body better. Whereas what we want to do is we want to stress the body enough a little bit so that all its repair mechanisms can be boosted up, and therefore you create your own endogenous antioxidants to help slow down the aging process.
Okay.
All right. So the other hallmark of aging is attrition of telomeres. So basically, telomeres are the end caps that sit on chromosomes. And every time a cell divides, the telomere gets a little bit shorter. So attrition, meaning the telomere gets shorter and shorter every time the cell divides. Once the cell no longer has telomeres, that cell dies. Okay. And so there's some tests out there actually that you can actually get an assessment of your telomere length. I don't know how accurate they are. But anyway, the shorter your telomeres, the quicker you're aging. It's the whole
Mm-hmm.
thing behind that. So that's another mechanism. And there are ways to help slow that down. Any alterations in the epigenome, so just so people know, we're talking about above the gene. So we're not talking about the DNA itself. We're talking about everything that influences the DNA. So above the DNA that influences it. So you can think about what's an epigenetic kind of mechanism. So let's say you go work out and you work out for a month or so, you put more muscle on. That's an epigenetic phenomenon. Basically, you're forcing your genes to help you make more muscle.
Mm-hmm.
You're turning on your muscle making genes.
Yeah, some stimulus there to kick this process off.
Right. And that's a pretty powerful thing, because if your environment definitely influences how much you age then.
Mm-hmm.
And so that's without a fact. So anything that you can do to make sure that environmental signals help your genes turn on and off appropriately will help you be healthier.
So what are some of those things other than our general lifestyle, which we definitely know? Exercising, sleep, those.
Yeah, exercise and sleep. We're going to talk about it. Intermittent fasting. That's a huge one. How about
so most of them
quelling your stress response, a lot of lifestyle stuff.
Right. Yep. That's exactly what I was going to say.
Yeah. Loss of protein maintenance, right? So as you get older, you start losing muscle mass, or you don't, your metabolic sensors don't utilize amino acids appropriately. That's another aging thing. So, and that goes right into nutrient sensing caused by metabolic changes. You can think about like a type 2 diabetic and how their metabolism is thrown off from, basically, you can think of lack of sleep or lifestyle stuff that brings them into type 2 diabetes. They have more insulin around, and a growth hormone, insulin-like growth factor. Both of these things have been shown to, the higher they are, the quicker you age. Mitochondrial dysfunction, these are the power plants of your cells. So that's also an aging process. A big one, accumulation of senescent cells. Cells that are kind of worn out but still alive, and what they do is they create inflammation, and they have a negative influence on healthy cells around them. So the more of those that you have, the more inflammation that you have, the quicker you age. So getting rid of them would be a good thing. Stem cell exhaustion. So we have stem cells. We were just talking about that. Stem cells can, you take a stem cell, and with the right signals, you can turn it into anything. You can turn it into a nerve cell. You can turn it into a heart cell. You could turn it into whatever if it has the right signals. And once it turns into what it is, it can stay that way. It will stay that way. But with technology, I think what we're going to be able to find is that we're going to be able to go forward and back with what a cell can do. And
Sure.
so stem cell exhaustion is a huge thing to help to know more about. And then basically an alteration in cellular communication. So any alteration in that would be a problem. So if you have high blood pressure or lack of sleep, that causes all kinds of dysregulation of cytokines and metabolic messengers that your body just, gets the wrong message over time. And if that keeps going on, yes, you age faster. So those are kind of the hallmarks of aging. So addressing all those seems to be where we want to go. And there's a lot of researchers all over the world that are starting to address these things. So if you address those things and improve those things, you live longer and live healthier now. Mm-hmm. But the really interesting thing and the really cool thing about this book is that there are things that you can do through your lifestyle and taking nutraceuticals or the way you eat that addresses every one of those in a positive way. Mm-hmm. So that's really cool, right? It's not like you need to take 100, thousands of different pills and antioxidants. Trust me, I have a lot of patients who come in with all these pills and antioxidants or address each one of those in a various way and take a kind of a medicine for each one of those to slow it down. It really boils down to simple things that you can do, and all of those kind of funnel into a couple metabolic pathways that slow it down. And that's where we get into these what we call longevity or vitality genes and ways to turn them on. And there's only a few of them in mammals, which is fascinating, right? So a few of these genes, longevity genes, if you can turn them on and off in the right way, you address all those hallmarks of aging in a positive way.
Okay.
So,
and those are things we just discovered we can do, or we just discovered that those.
This is fairly recent. It's fairly recent. Like the discovery of these longevity genes or vitality genes is probably a better word. It's only been since the 80s, 90s, and the research is getting more and more on them. And specifically, there's a few of them out there, but one group of them is called the sirtuins. All right. And in mammalian genes, there's seven sirtuin genes. So they're called SIRT1 through 7. And they're made by almost every cell in a mammal's body. But they're actually found in all, in almost all animals. Okay. So as we evolved, as primordial cell evolved and billions of years, and then here we are, these sirtuin genes with animals have helped them basically either resource allocate to help them reproduce quickly, or resource allocate for longevity to help them reproduce slowly, but they live longer. Mm-hmm. So they're in almost all cells and in almost all animals, and certain animals, based on how they resource allocate nutrients and their lifestyle, will actually live longer. And humans, actually, what we're finding in the studies, if we turn on these sirtuin genes, we can actually significantly slow down the aging process. And it doesn't go. The reason why I want to talk about that, the nuclear DNA, as kind of like, we don't really have to focus there so much according to the science, right? Which can really get complicated. Like there's, what do we have? Like 23,000 genes. And then those genes are influenced by other segments of DNA and, all these messages back and forth. I mean, it's really going to take like artificial intelligence to really make sense of all that, that's probably, hundreds of years into the future to really make sense of how all that communication works and to just flesh out all the details. But what's really fascinating about DNA is if you can activate these sirtuin genes and these other vitality genes in such a way, you actually take care of the DNA, and something that's already very easily copied and can be passed on is even protected more. Okay, so the human cells, what's fascinating about it is that we have a digital way of copying our cells, right? And we do that through DNA, right? Okay. So it's like DNA is a digitized way to reproduce, and it has very high fidelity, and it makes very few mistakes when it gets passed on to the next generation. And we saw that. That's why I want to bring up that cloning thing, where the DNA seems to be highly protected or has such high fidelity that it doesn't even matter when you clone animals from an adult cell, that animal actually does pretty well. So there's other things going on than just the DNA. And we talk about the other things of aging, the hallmarks of aging, the other aspects of aging. That's what we want to focus on. Mm-hmm. So we don't really have to focus on the really complicated part of making sense of how all this DNA and the genes interact with one another and all that. It's like fascinating to me that it's actually narrowed down to just a few genes that we have to just look at, mm-hmm. that take care of everything. Mm-hmm. They're like master switches. Mm-hmm. So anyway, do we know what those genes are yet, or no? Yeah, so we do know what they are, and there'll probably some others that are out there, but the main ones that we know are the sirtuin genes, right? There's other ones out there. There's another gene called TOR. TOR stands for target of rapamycin, or mTOR, mammalian target of rapamycin. I know that name sounds very bizarre to people, but let me just give you a little bit of background on how that name came about. So rapamycin sounds like an antibiotic, which it is, okay? But in the search for antibiotics, there's a scientist who actually went to Easter Island. And I think in Easter Island, it has a specific name that is like Rapator or something. I don't know the native name. But anyway, they found a bacteria there that actually created this type of antifungal medicine called rapamycin. All right. And what rapamycin does is it keeps fungus from, destroying itself, the bacteria. So the fungus won't eat the bacteria. So it secretes this rapamycin. So rapamycin is kind of an antifungal. So they found this antifungal, it's an antibiotic. And what they found was when given it to mammals or humans, it slows down all these hallmarks of aging. All right. So there's a drug out there called rapamycin, and it actually can slow it down. The problem with it is it's not on the market or heavily on the market or prescribed heavily because there's lots of side effects to it, but it actually can slow down the process of aging. And it does this by influencing this, TOR, this mTOR gene. All right. So that's another, and that's that mTOR gene is like a master driver of cellular growth. So it targets that.
But people should not run out and start seeking this medication.
No, there's better ones. There's better ones out there. Okay. Although people have taken it, but you definitely, there's other ways to go about it.
Okay.
So anyway, when mTOR is inhibited in the body, it signals cells to kind of hunker down, and it improves survival by boosting DNA repair, reducing inflammation caused by senescent cells, and it ramps up signals that say get rid of all the cellular debris out there. Okay, So when that gene is inhibited. Another one is called AMPK. Have you heard that one? So, okay. So basically it's AMPK, activated protein kinase. It's basically a metabolic control enzyme. When activated, it stimulates energy. It basically is a master switch for metabolism. So it regulates glucose uptake, fatty acid oxidation, decreases energy consumption of like proteins and lipids. So the sirtuins, mTOR, AMPK, all of these things get upregulated when there's a little bit of stress in the body. So a little bit of stress actually helps you upregulate all these anti-aging biochemical mechanisms in the body. And so what are these stressors? So think about us from an evolutionary, us humans, is feast or famine. Right. And so you go through these stress times, and these stress times are kind of like, cleaning out doing the spring cleaning of the body, so to speak, cleaning out the whole cobwebs, cleaning out the cellular debris in the body when you're going through a little bit of stress. Too much stress will kill you, right? So it's not like a stress where you're getting eaten by a Tyrannosaurus Rex, but a stress where you are, going a couple of days without food actually regulates these things and slows down the process of aging. Yeah. So what are the other stresses out there that we can use in our modern day life? Well, exercise is one. Another one is eating lower animal protein diets. So animal protein seems to have kind of activate some of these aging mechanisms in a negative way if you're eating huge amounts of animal protein. So eating more plant-based proteins, stuff like that. Intermittent fasting is another way. Exposure to hot or cold temperatures. So both seem to add a little bit of stress. So we talked about who's the Iceman, the guy who would
Wim Hof.
Yeah, Wim Hof, right? So that's what he's doing is stressing the body in such a way that he's slowing down the aging process, upregulating his immune system, so much so that he's just a healthier person for doing it. And it's like that whole Nietzsche saying, right? Like, that which doesn't kill you makes you stronger. That's kind of what this is. And in modern medicine or in science, we call that hormesis. So a little bit of a toxin actually makes you stronger. A whole lot of a stress or toxin can kill you. So basically what we want to do is we want to add a little bit of stress that allows hormesis to happen so that you upregulate these anti-aging mechanisms in the body. And it basically talks to these genes, sirtuins, the mTOR, the AMPK, and turns them off and on in such a way that slows the aging process. Now, so those are basically lifestyle things. Oh, and the other thing we didn't add to that is me and you, we did that whole series of podcasts on sleep.
Yes.
We know sleep is another way to help clean out the body. So you can think about your waking life as a little bit of stress. So, and we know that if you don't go to sleep, eventually it will kill you. If you never go to sleep, you're going to die quickly. But what happens during sleep is you get cleaning out of the brain, the body functions better, so on and so on. So sleep should be added to that too. So these are some things that you can actually do to slow down the aging process. But with that being said, there are actually complementing these lifestyle things, actually hormesis mimicking molecules out there that are very safe to take. And one of them is called NAD. So that's nicotinamide adenosine dinucleotide. And this compound is the compound that is kind of the currency for these genes to work better.
Okay.
All right.
Yeah.
So you can take these compounds, and what we see in some of the studies is these compounds actually turn on and off these genes so that they work better. So cells that have a lot of NAD floating around just function better, do better, are aging slower. There's
and that's something you can take over the counter.
Yeah, that's something you can take over the counter. Yep. And then there's another compound out there called NMN. And NMN is, again, it's a nicotinamide type compound. And it's found in foods such as broccoli and avocado. And when you take that, it actually has more of a profound effect than just NAD. You get like a 25% increase in NAD when you take this compound. This is just stuff you can buy over the counter. These are supplements that I carry in my own clinic.
But your body also makes its own natural NAD, correct?
It does. Yes, that's exactly right. These are not foreign compounds to the body.
Yes. Okay. Which goes back to what you were saying earlier. All this is about kickstarting our internal process.
Right.
We already have. Okay.
Another compound that our body does not make is called resveratrol. And I'm sure people have heard about that, right? Because, people heard about it being in wine and things like that. Resveratrol is found in like peanut skins, certain skins of fruit like blackberries and certain seeds. But especially it's found in like red wines. But there's the herb that they process or get it from and put it in supplements is a herb called polygonum. It's really interesting. In Chinese medicine, polygonum is considered a longevity herb, and lo and behold, it has tons of resveratrol in it. So it's one of those. It's kind of funny when Eastern medicine meets Western medicine and the science, and you kind of make sense. Mm-hmm. So resveratrol is found in the Chinese herb called polygonum, and it was always given as longevity herb, but resveratrol is in huge amounts there, and the science shows that it really helps turn on these anti-aging mechanisms. And then there's another one that I'm sure everybody's heard of, but they may not know where it came from. But metformin. Metformin is actually a prescription drug, and it's given for diabetes, and it mimics caloric restriction. It helps nutrient allocation, resource allocation. It's given for diabetics. Low dose metformin is actually something that a lot of people in the anti-aging community are taking right now because of all the anti-aging stuff that it can do. Mm-hmm. And it's very, very cheap. So metformin is one of my most favorite prescription meds as far as preventing disease.
We talked about it on a few episodes.
Yeah. So you're talking about, it's shown, if you take it, it's shown to decrease cardiovascular disease, definitely cancer. The list goes on with it. And it has it does have some digestive side effects. Some people don't tolerate it well, but it's very, very cheap to get, and it does a lot. And then we talked about rapamycin, but that's not really one that you want to get. There are people who do take low dose rapamycin for it because it also mimics caloric restriction, but I don't think it's that readily available for some people. And I'm just not sure the safety profile is all there like it is with metformin. And by the way, metformin was derived from an herb called Galega officinalis, which is actually an herb called goat's rue. All of these compounds, like resveratrol, NAD, NMN, they're actually called sirtuin activating compounds. So they activate the sirtuin genes. The acronym is called STAX, and they're just chemicals that have shown to activate these groups of anti-aging genes and just slow down the aging process. So anyway, I recommend the book, which is Lifespan, Why We Age and Why We Don't Have to by Dr. David Sinclair. He goes into this in pretty good detail, and you don't have to be a scientist to understand it. It's like really, I think it's written really well for lay people.
Awesome. And that was kind of the guide for this episode. It talks all about this.
Yeah. Talks all about it. It goes into a lot of detail about it, but really just I think it's fascinating because we've been talking about this for a while, and it's like you don't have to do much to help your health, you know.
Yes.
It's just lifestyle stuff. I mean, I recommend to all my patients now, when it's appropriate, you know, like I definitely recommend intermittent fasting across the board to adults. I mean, I certainly wouldn't recommend it to growing, you know, people, kids, teenagers, and stuff like that. Certainly not pregnant women. But for most adults, intermittent fasting is a really good thing to do as long as there's like no eating disorders and things like that. And again, intermittent fasting is putting more space between your meals and just adding a little bit of stress to your life to activate these genes.
Yeah. Anything else, Keoni? Obviously, a bunch of lifestyle things that we got, and we talked specifically about NAD, NMN, and NMN is something I can also get over the counter.
Yep, you can certainly find that over the counter. You can certainly, metformin's are pretty readily available. Usually you need a script for that. The NAD you could certainly get. I use a combination product that usually has like NMN in it, along with some other vitamins in there that can help it work better. There's combination products with NAD and Resveratrol in it that are good. But yeah, these things you can get over the counter, and you can find them pretty easily from doctors like myself, or it is interesting. I did months ago, stopped by a GNC or like a vitamin shop place, and they didn't have any of these products out yet, but I know you can get them through Amazon or anything like that, but they may be there now.
Yeah.
In the book though, just so people know, it's Dr. Sinclair like kind of lays out his kind of protocol about what he does. And, you know, some of it is like really, really kind of easy, and, you know, things that we all should do. Like, you know, don't smoke, you know, try not to microwave food in plastic, you know, drink plenty of water, minimize your exposure to, you know, radiation, whether it be from like excessive sunlight out at the beach or getting sunburns, or like x-rays, CT scans, that type of thing. Try to keep your BMI in a certain range. You know, you definitely want to keep it where you're not overweight. And he just lists out what he does, and he lists out like trying to fast and things like that. He lists out that he takes quite a bit of NMN every morning, and not so much NAD, because NMN seems to, according to him, work better than the NAD. I personally take all three. I just do all three in very low dose on a daily basis. So I do the NMN, the NAD, and the resveratrol, and just part of my supplement regimen with that, along with intermittent fasting. And the way I usually do it, I don't know if you intermittent fasting a lot. I mean, I do, like, I try to do two meals during the week. Maybe I'll do one meal during the week, and then usually on the weekend I may do 3 meals. But I definitely cut back from 3 meals a day, or 3 meals a day in snacks. So that's kind of like my maintenance intermittent fasting thing. And every now and then I'll do a prolonged 24, 36 hour, but I do that like once every few months, if that.
Mm-hmm. I am intermittent fasting based off need. Oh, shoot. I'm busy today. I'll eat at 7.
Yeah. So you're doing it based on okay. Yeah. It is something I really do think that is something that everybody should start doing.
Mm-hmm. And then with that, just to clarify, and I know we have a whole episode regarding it, but just to get people started, when you say get people doing it, you know, what is the threshold? Is it 4 hours, 5 hours, 6 hours? You know, where does someone need to start if they haven't done it before? And then also, just to add to that, how often are you recommending this? Once a week?
So this is what I tell my patients. I tell them intermittent fasting is relative to yourself. Okay. So it's just putting more space between your meals or feeding times than you normally would. So somebody who is like wishy-washy, doesn't really know, or is a little bit nervous about doing that, and eats 3 meals a day with snacks in between, I would say just start out without doing snacks.
Okay.
And see how you feel. That's intermittent fasting.
Perfect.
And do that most days. And if you can do that, then and you feel fine. Most people feel really good when they get into it. And then if you can do that, then every few days, just try like skipping a meal every now and then. So do 2 meals a day. If you can do that, then, and this is not every day, like you do it, whatever fits your schedule. And then if you can do that and you're at a comfortable place with your fasting, because remember, if you get really comfortable and you're like, well, I intermittent fast anyway, and I do 2 meals a day, and your body recognizes that not as a stress, well, you want to add a little bit of stress to the body.
Right.
Okay.
Right.
So
that's a good point.
So periodically, it doesn't have to be every day. So I have some patients who would say, well, I only eat 1 meal a day. I'm never hungry anyway. And actually, when you get into it, you actually find that they don't. They're usually drinking sweetened tea throughout the day, or they're snacking. But if there truly is a patient who does 1 meal a day, and they've been doing that for years, and they don't want anything else, and I say, okay, well, intermittent fasting to you would be, okay, maybe skip a meal, skip eating one day.
The meal.
Skip the meal.
Yeah.
One day here or there. That would be intermittent fasting for you. So
it's got to be stimulating.
It has to hit a threshold that is a little stressful, like where you feel hunger. So that's the thing.
Yeah. All right. I think that gives us some good stuff, both lifestyle and obviously the NMN and resveratrol and all those other things.
Yeah, those things I think are kind of like the new supplements on the rise, and the anti-aging supplements, and they're very, very safe, and your body makes both of those. So that's what I think is great about them.
In the book, again, David Sinclair, what was it?
So the name of the book, here's the book. I don't know if people can see. Yeah, Lifespan, Why We Age, Dr. David Sinclair. So
anything else, Keoni?
No, that's it.
Well, we'll see you for 100 years to come, everybody.
Oh, I hope Bryan, maybe we're going to be doing this podcast 100 years from now and be like, yeah, oh boy, thank goodness we did this.
Yes, thank goodness we did this.
That's right.
All right, everybody, we will talk with you next week, and until next week, be well.
Take care, everybody. Bye.